I'm Bob Sandheinrich. I'm a developer here at Wolfram, and today I'm going to be talking about some fun side projects I've done. So today I'm talking about quickly turning fun ideas into projects that mostly work. So I've been working at Wolfram for a while. I've given a few talks, and up until now, they've all been sort of about my job. And I try to make the presentations fun, but usually the subject matter is kind of dry, and it's important, good stuff to know about. But this one is not about my job. This is about what I do for fun sometimes with Wolfram Language when I'm not even getting paid to do it. So, and as you can see there, there will be jokes, and due to the remote virtual nature of this, I will just assume that you all find them hilarious. All right. So like I said, I've been at Wolfram for a while now, and I do almost all of my development in Wolfram Language, and this has side effects. So the sort of computational mindset has crept into my brain, and it affects the way I think about things. The Wolfram Language is highly automated. This has benefits. If I want to pursue something in the Wolfram Language, it can happen quickly. And the most important thing that can happen quickly is finding a dead end. So if you want to go down some path just for fun, you don't want to waste a bunch of time, and you don't want to spend a bunch of time just to learn if you're wasting time. Then you'll run into sunk cost issues and end up wasting more time on a dead end. It's terrible. But everything's highly automated. You can get a proof of concept and a prototype in minutes for most projects. And that's a huge benefit. And then another thing that's important, the Wolfram Cloud exists and is getting better every year. And this has consequences. And that is, you are all going to be subjected to my hacky side projects. And also, you can whip out your fun hacky side projects at all those cocktail parties that we're all going to, and they can see the cool things. You can send them a link, and they'll see it on their phone and be like, "Ooh, there's a thing that does a thing. How is that happening? It's magic." So this presentation is basically a rundown of 3, if we have time, maybe more, quick, fun, hacky side projects, or as I will call them, KFIPs. All right. So the first KFIPs is Pie Slices Daily. Pie Slices Daily, I'm going to sort of break down the origin story about how it came about, and then we'll look at it at the end. So if you are familiar with my Pi Day, if you follow Wolfram on Twitter, then you probably have seen, browser's on the wrong screen. Here we go. You've probably seen my Pi Day. It's a website. You go in, you put in your birthday or any day. You can lie. You can tell us whenever you want. And it tells you where your birthday is in Pi, and you can get a t-shirt. And, beautiful, beautiful design work. But every year this sort of gets a spike of traffic. It sort of re-enters my consciousness. And what's really amazing is that, like, the computational part of this is super trivial in Wolfram Language, right? So it's almost this. This is what I'm using to make a slice of pie. So it says, give me 15 digits of pi starting at the 20th digit, right? So if we look at 35, it's the last 15 here, right? So, and you can go pretty darn deep, and it doesn't take too long, right? So 2 million digits in, and that took less than a second. So getting digits out of pi is amazingly trivial. I'm not a math expert. I don't know what algorithms are used here. I know it's impressive, but I like to use it. All right, so the next piece for Pi Slices Daily is a Twitter service connection. So service connections have been around for a few versions now. And what you can do is you can say this. It takes you to your browser. I'm logged into Twitter. I can authorize it. It says, go back to Wolfram Language. So here I go back. And now I can use Twitter from my notebook. So I can say, get all the tweets from Wolfram Research. And so here's all the last 20 tweets or something. Oh, look right here, they're talking about me. All right, and then importantly for this conversation, there's also a way to send tweets. So instead of saying tweet list, I can say tweet, and I can give it a message, and I can tweet this out, and then I'll go back to Twitter here, and see here's my tweet. All right, so that's fun. So that's the second piece. The third piece is cloud deployed scheduled tasks. So scheduled tasks running in cloud have been around for a while, but I don't think people use them enough. So I'm going to advocate for them because they're very powerful, and they really let you make fun products in the world. So here I have some code that's not very impressive. All right, so you can take the temperature in St. Louis, subtract the temperature in Champaign, and I added a little timestamp to that, and I'm putting it at the end of a cloud object. So every 6 hours this is going to run in cloud. So it's just going to take the difference in those temperatures and put it in a cloud object. So I have this scheduled task that has been running since I started putting this talk together 2 or 3 weeks ago. And now if I use read list on this cloud object, I get back all of these timestamps with temperature differences, and I can plot it. So, the computation, the code here isn't revolutionary, but scheduled tasks in cloud work, and they let you just sort of create things that are effective. So we got those 3 pieces. We got slices of pie that are super easy to get. We've got tweeting from Wolfram Language, which is super easy. And we've got, I got to reach up higher for you to see it. And we've got cloud deployed scheduled tasks. And the end result is Pie Slices Daily Twitter, one of the greatest web pages in the world. 11 followers, that's 1 more than yesterday. So every day for over a year now, it's tweeted out the next slice of pie, 280 more characters of pie. And my dream is that one of you will verify that it's correct. And if you find wrong one, I will send you a sandwich from Uber Eats. All right. And if you want to see the code, it's here in my GitHub. So this is all 195 lines which is probably half white space. So yeah, and most of this is just error handling. Whenever you're doing sort of server to server communication, you need to handle it when somebody just sort of completely falls over. So half of that is just for error handling. All right, so that was our first KFIPS. Now we can move on to our second KFIPS, random haiku generator. So I work with the function repository a lot as my actual job. I develop it and I review some content for the function repository. And about a year ago, Mark Greenberg published word syllables. So this is a function that what it does is simple, but how it does it is surprisingly complex. So it just takes a word and splits it in syllables. Seems like that might be an easy thing, but linguistics is tricky. So, but it works well. Like I can rarely find, I think only once I've seen one that it got wrong. But I saw this function that was, some serious coding and required, expertise and study. And I decided I could do something stupid with it, something quick, hacky, and fun. So I made another resource function, random English haiku, and so it just uses that syllables to split up words and then finds words that fit into a haiku, and it works. So that's in the function repository as well. You can see it here, but that's, in my mind, doesn't qualify for a full-fledged KFIPS because there's got to be some web stuff. So I'm not a CSS person, but luckily I know someone who is, and I got him to spend 4 minutes making this, and what I have here is cloud deploy of delayed. So that delayed means that every time you visit the cloud object in a browser, it's going to rerun the code within it. And then what we have here is it runs random English haiku, and then make sure that it works. And if it works, then it exports it within this that HTML blob with the CSS in it to HTML so that it looks good. So I deploy this to a cloud object, and now we get something that looks so poetic. Oh man. Bell birdie jiffy, drill untagged arrangement. Cowherd morosely. See, it just tickles your soul that way. All right, so that is the second quick, fun, hacky side project. And the third one is one that I'm most proud of, that I love the most, and that's this baseball reference player graph. I'm a big baseball fan. Hopefully, there's some other baseball fans listening. And if you are a baseball fan, you probably know about baseballreference.com. So baseballreference.com is a statistical wonderland. This website that's basically just an interface to a database has been around for an amazingly long time, something like 20 years since all of the internet kind of looked like this. And it has, importantly for us, for each year, 2020, Los Angeles Angels, it has statistics pages that include rosters. And it also has some other pages that are important to us. So I have all the code that's running here is in my GitHub. I'll say again here, you can see this is 100 lines of code. Again, a bunch of white space. So it's not a whole lot going on here. Most of it is basically this: import of a web page as an XML object, some sort of pattern matching in cases to find some content in that web page, and then grab those associations or create associations from that content. So that's mostly what's going on here. So the first thing I did was I took this page, which just lists all the current teams in Major League Baseball. So here we have the teams so team names and relative URLs on Baseball Reference. Then we can take one of those teams, and I have this function team years. So this says the Boston Red Sox, every year they've been around. They've been around for a long time, since 1901, the founding of the American League. So you can see they have 120 years of teams. So that means each one of those past was one of those pages with the roster and the statistics that we looked at a couple minutes ago. Then what I have is this guy, team year player graph. So what that does is it takes the list of teams and years they've existed. So basically, if I had done this team years over all the teams, it would create the thing that's big and ugly inside this iconized blob. So it takes that set of teams and years, and then you can give it a start year and an end year. And I'll run this. Last time it took about 20 seconds. So while we're running that, I'll tell you what it's doing. It's making a graph where each vertex is a player that was in Major League Baseball at the time. There we go, 15 seconds. It's getting faster. Let's plot it. That takes a few seconds too. And each edge represents a teammate relationship between two players. So if two players played on the same team in the same year, they have an edge between them. Now, I know what you're thinking. You're saying, Bob, what if two players were traded for each other? That means they played on the same teams in the same years, but they were not actually teammates. And you know what? You're right. It's not perfect. This is a quick, fun, hacky side project. All right, so we have our graph. And so now that we have this computational form for this data, we can do all sorts of cool stuff. So I can grab two vertices, and right now they're represented with Baseball Reference's ID system. But for any two players, I can find a path between them on this graph. And this team year players graph, in addition to making the graph, also added annotations. So I can get their real names, and I can see that Jesse Jefferson played with Rick Burleson, who played with Jim Dwyer, who played with Dallas Williams. So now we have this cool computational thing that you can play with on your desktop computer, and we're done. Just kidding. Cloud deployment. So we can take this graph and export it as MX to a cloud object. I did that earlier. It only takes a few seconds. And then what I can do is I can create another cloud deploy of delayed. Again, this means every time you visit it, it's going to run again. And it's calling this random story function on the graph. So this imports the thing that we just exported, the graph. And then it calls random story. And then it exports it as a cloud CDF. So when we visit this, we get this random story. Steve Crawford played on the 1981 Boston Red Sox with Carney Lansford, who played on the 1980 Los Angeles Angels with Ed Halicki, who played on the 1980 San Francisco Giants with Alan Ripley. And if we refresh it, we get another story. Okay, so that's fun, but that's just 1980 and 1981. What about the rest of them? Well, luckily I've done the work for you. The scraping took a couple hours, and the result is this one. So now we've got Earl Yearling and Jack Delorio. And you can see maybe some names that you recognize. Let's get another one. Oh, this is perfect. Notice who's in the middle here. Minnie Minoso, Harold Baines. Remember those names. So this is connecting a player from 1951 with 2016. We'll go again and see if we can get somebody from way back. 1906, but he was only going to 1935. Anyway, so this, if for me, is solid minutes of fun. And if you're a baseball fan, I wouldn't be surprised if it's solid minutes of fun for you. Since we have this computational graph of this fun new data, I figured I'd point out a few other things. There are 17,669 vertices representing players, just over 2 million edges representing teammates. The graph diameter is 9. So that means any two players are connected to each other by at most 7 other players. And I pointed out Minnie Minoso before. Minnie Minoso is the Kevin Bacon, Paul Erdos of Major League Baseball. This is an important finding. Minnie Minoso is one of 1,388 players that are connected to all players in 5 degrees or less. The top 20 players by between centrality are these folks. So this is why I have Minnie Minoso. It's a great story, so indulge me for a minute. Minnie Minoso was one of the first Cubans in Major League Baseball after Jackie Robinson broke the color barrier. One of the first dark-skinned Cubans. There was all sorts of weird racism before that. But he played a long career. And then after he had retired from playing, he was a coach with the White Sox, and they had a player shortage. I don't remember the reason, injuries or labor dispute or something, but they needed a player, and they said, Minnie, you want to play? And he played a handful of games in his mid-50s. And one of the young players on that team was Harold Baines. So between these guys, you can connect all the way from like 1950 to like 2003 or something. So these guys are like this great link. The other players on here also had long careers. Some of them, like Julio Franco and Nolan Ryan, played on a bunch of teams. Also, I've done further research that I think is very important. There are many people with Bacon-Minoso numbers. There's, Jackie Robinson played Jackie Robinson in the Jackie Robinson story, so he's in a movie. Whenever they make a baseball movie, they cast some real players as extras to make it look real. But as far as I've known, with my extensive 20 minutes of research, I don't think there's anyone with a Minoso-Erdos number. No Major League Baseball players have published in an academic journal. I could be wrong about that. There's a lot of retired baseball players that become MDs, but I haven't found any publications from them. Another takeaway, old-timey baseball names are great. That might be my next KFIPS. All right, so that was the last one that I really wanted to point out this morning. A new CFIPS just for you guys. Let's see. Giphy importer. All right, so I'll just summarize that. When you encounter things in life and they seem like they might have some computational interesting aspect to them, pursue it, because you might get something fun. You might get something useful. None of that was really useful, but it was fun. And if it turns out to be a bust in the Wolfram language, you're only gonna waste a half hour. So I am computationally fun, and so can you. Signing off.